Hello everyone, welcome to Identity and Access Management Level 200 course. My name is Flavio Pereira and I'm a part of the OCI Field Enablement team. If you didn't watch the Identity and Access Management Level 100, I highly recommend that you watch that course first so you can get a basic understanding of IAM and follow along with that lecture. Here's our safe harbor statement. I'm going to pause for a few seconds so you can read the statement. All right. So on this lesson, we are going to go and talk about instance principles, advanced policies, federation, and we look at some reference models for enterprise that have moved or running on OCI and how they have constructed some of their security principles using federated access. So here's a IAM basic portion. So identity and access management lets you control who has access to your cloud resources. You can control what type of access or group of users that have, right, and what specific resources they can get access to it. So in IAM, you're going to use components that are described as users and groups, right, the service instance principles, the authentication and authorization through a password or even to API signing keys, right? Policies, you want to be able to write policies. There's a syntax policy you have to write in order to give the specific access, and compartments, right? So how compartment works in OCI and how you can isolate resources through compartments as well. All right, so let's start with instance principle. So instance principle is a method that helps us to solve a security challenge, right? So if you need to interact with OCI from a server where we have a code or an application, right, that's running a code and that's running the compute resource, and that app needs to interact with object storage or needs to stop and start an instance resource. So that means that it needs to go and authenticate against OCI. So it needs to have permission to interact with the API. Now, one option to resolve that problem would be to give to your code, your application, a IAM user, for example, an API signing key, and then store those credentials inside of the server or inside of the application, right? So as you can see, it works, but it's not actually a really good option because you're actually storing credentials on the application. So you have to keep rotating those credentials on a regular basis. And if you have multiple compute resources, multiple applications, you have to change the credentials for each one of them, right? You can see how that can be a huge problem, right? So instance principle will allow us to basically allocate permissions to a compute resource and then take care of the authentication and the credentials that were utilized by the server when it needs to authenticate, right? So to give more details on it, so the instance principle, it's basically associated by a dynamic group, right? We associate one or more compute resources with that specific dynamic group, and then we assign permissions to the group just like we would for a regular user account. So the nice thing about it is that any requests that are actually executed by that server will show up on the audit log. So you can track what actions were executed by that specific instance, so you can see in audit logs everything that's happening when an action was executed. So here's an example of a dynamic group called front end. And as you can see, we're allowing that instance called web server 01 to use the instance principle. We're getting the OCID of that instance and we're adding that on the matching rule of our dynamic group, right? That's going to give you the ability for that instance to use, take advantage of the instance principle. So the second portion, the second step of that is actually create a policy to give specific permissions to the dynamic group, right? So you create a dynamic group, you associated the instance to the dynamic group. Now I can write a policy towards to it, and that's where the flexibility will be really great. So I can write a policy and give specific permissions to that instance. On this case right here, I'm allowing a that instance, right, to manage buckets in the tenants and objects, right? Pretty much working with my object storage. So this authentication method, right, is made possible through the SDK that OCI publish. So when you install the command line interface, or when you're using Terraform, those tools, they have developed it to automatically include the instance principal functionality on it. So on Web Server 1, if you go to the terminal on the Web Server 1, if you try to access the object storage without using the authentication instance parameter through the command line, my access will be denied. Right. So first will be denied because I didn't pass the authentication instance principal, and second is going to be denied because I don't have access to the API signing key, right, for that user. But as we add that instance as part of our instance principal, as part of the dynamic group, even if I comment out the API signing key here on the file and executed the command again, but this time using the instance principal authentication parameter, you can see I can get the results of my command, so I can get access to my object storage. So you might be thinking like, hey, how that works, right? So the authentication happens at the instance level. So when you allocate it, or when you associate a compute resource with that specific dynamic group that was created, there is a token service that basically gets set up to broker the credentials between that server and the OCI API. So that token is rotated on a regular basis. So the certificate is valid for 60 minutes, but the token is automatically rotated every 30 minutes. So there's nothing that you can do to just just creating the group, right, and associated the resources with that group. So OCI will take everything else about the authentication on the back end. So if you want to see the certificate that was generated for your instance, you can actually query the metadata server, right? The 169.254, 169.254, that's the metadata server. If you type the URL using a curl command, you can get access, you can see the certificate, right? You can see the certificate created for your instance. All right, so let's talk about advanced policy configuration now. So on IAM course level 100, we talked about the specifics, the basic policy configuration and syntax, and just here just an overview of that. So you can see a policy syntax right here. In terms of subject, you can use groups, right? You can use one group or multiple groups, or even the OCID group on the subject. The verbs you can use for your policy. For example, you can manage, you can use, or you can read, or you can inspect a specific resource type. The resource type can be the whole family, the aggregated resource, or individual resources type, right? You can do you can manage, for example, subnets on a specific location, which is the compartment or a tenancy, and you can have some conditions as well. So you can pass some conditions along with your policy syntax, right? So now, beyond the high-level syntax at the resource level, there are a number of API-level functions that's happening, right? So, for example, for compute instance, and I'm going to just go here on this slide real quick so you can see all the verbs permissions and API operations. So just one example, if I have a compute instance, I can create list, terminate, or start and stop, and each one of those actions that I'm executing is actually an API function that's happening behind the scenes. So that means I can go a little deeper to say which function specifically am I allowed to access, am I allowed to execute, right? I can be very specific and say something like, I'm going to give you access to a volume family, right? However, I will allow you to list, right, and read and update a volume, but I don't want you to actually terminate or delete a block volume. So I can be very specific on which API function that can be executed. Okay. So this is my policy statement. So you could have a condition that says something like, allow my group to manage volume family in the tenancy where the request dot operation does or does not equal to a particular value, right? So I'm using the request operations here to identify that specific API function that I want to be executed. Another example could be allow compute admin to manage instances in a tenancy where the request operation does not equal is different, right? Different than terminate, right? So they can do everything but terminate the compute instances, right? So as you can see, this allows us to be very granular in terms of control of what groups can and cannot do. It can be based on permissions, it could be based on region, right, compartments or groups. So we can see an example here on the bottom, example, right, allow group Phoenix admins to manage all resources in the tenants where the request regions is Phoenix. So that means I'm going to allow the individuals that belongs to the group Phoenix only to manage resources on the Phoenix region, right? All right. We can also do pattern matching, right? And on those conditioning statements. So if I had a series of group, for example, here on the example I have, I can have HR admins, HR managers, or HR users groups, right? I could say you're going to have access to those resources where the request group ID or the request group name has to be equal to HR star, right? So I can actually matching one of the patterns here in order to create my policy syntax and give that specific as well. Right? You can see more examples of the request operation function when combining we actually with the pattern matching, right? On this first example, I'm saying allow group admins to manage groups in the tenants where the target group name, so I'm using the request operation function here, right? And I'm combining with a pattern match when say all the groups that say all dash users dash star only those groups I'm going to allow the group admins to manage and control. Okay, so you can see how powerful the IAM management tool can be as we can really get down to the specific API calls, specific functions, and be very intentional about allocating access to our users. So this is critical, right? Really critical for maintaining least privilege access for OCI account. Just one more example here. So we're going to allow training group manage virtual network family so they can do all the networking stuff on the compartment as long as they are not trying to delete stuff, right? On my request permission here. So they can create subnets and all that. Now the caveat here, they could delete subnets. They could delete a secure list, right? I'm just saying they cannot delete a VCN, but they can delete all the things that belong to a VCN. So you might want to think about expanding the permissions, right? To set and give the specific request operations for that policy, and then protect your VCN or all the components of the VCN to be deleted. All right, so let's jump in on Federation here. So I'm going to run through some of the best practices for Federation, and some common practice here, because most of the organizations, they already have an identity store And we are trying to avoid recreating the wheel here. So if the users are already logging somewhere, it can be an Active Directory, Identity Cloud Services, or even third parties single sign-on. We don't want them to recreate the user accounts in another system, right? So what we can do is federate access through either Active Directory or Identity Cloud Services and OCI. So those are the two methods supported in OCI, and allow customers to reuse their existing identity store, right? So now with that, there's a couple recommendations, right? When we create the OCI account, when you actually sign up for the OCI account, you get a default admin user, and that user is the one that you're going to be used to set up Federation, set up all the groups and permissions for federated access. So when the Federation is complete, it's really important to have like a backup process or a local user that actually can gain access to your account. What happens if the Federation access goes down, right? If the connectivity break between the OCI or identity store, we always want to maintain a couple of IAM users just for fallback, just in case you don't have access to your identity store anymore, right? So best thing is create a local user use a complex password. And secure that information, right? Once you have the Federation set up, configured, you shouldn't be using that user to authenticate anymore. You're going to go through the Federated, but it's always good to have a user in the back pocket, so in case something went wrong with your Federation configuration. So let's go talk about some IAM reference model for enterprises, like how are they actually doing some of the configuration there. So when it comes to authentication, it's important to understand the different authentication methods that we have, right? So when you logging to the console, right? That's one way to authenticate. Are you using a SaaS app to interact with OCI, or are you running a code outside of OCI, right? So it's important to know which authentication entity is necessary in order to access or interact with the different resources. So as an example here, let's say a code running on OCI using instance principle. If you're running that code on your laptop or a server in your data center, you can still interact with OCI API calls. You just have to have an IAM user and an API signing key, right? So you still have that. So this is important to understand where the authentication came from, right? So compartments. Compartments, let me just go here real quick and show the bullet points, and I can talk through. So compartments allow us to create a logical place of isolated segment on the infrastructure. When I say isolated in terms of authentication, so we can still connect resources across compartments, so that's still possible. We can connect networks, we can connect compute instances between compartments as well, right? So when I say isolated, I mean just the way you construct the resources inside of the compartment, but they can still talk to each other, right? What we do is actually build this compartment to identify or to control who can interact with or manage those resources from a security perspective. Right, so when it comes a time to build, for example, your dev, test, and production environment, right? So you might have two compartments, network, infra, and the production network, right? So we don't want overlap of dev or test and production, not only from a network perspective. We're not going to connect those networks together, right? But we also, from a security perspective, we may want the team that has access to the network. They don't have access to resources, specific resources like compute or storage or block volume, right? So what you're going to do is you're going to put in a different compartment with different permissions. So we won't be as granular as possible when it comes to allocating access to these different resources, but that those teams they'll go off and, let's say, the network go off and build the network layer, the subnets, route tables, secure lists, and defined. That was defined by the infrastructure team, right? Then on the other hand, you might have the ops team that can build and create storage, database, compute resources, and actually use the network that was created by the network team, right? So there is a logical isolation here, as you can see. So my network team, they don't have access to any of those resources, so they cannot terminate a block volume or compute resources or database on that case. And if you think about it, the flip side of it is that the ops team can also they won't be able to affect the network. They won't be able to delete any of the subnets or any of the internet gateways or secure list that was created by the network team. So they have to conform with the standards that were designed and defined by the network team. So if I want to actually put what I just said in policy statements, right? If you want to write a policy statement to actually accomplish what we just described on the earlier slide, as you can see here, the network team would have access to manage virtual network family in this specific compartment. They can also launch their own compute resources, as they have a policy here to they're going to allow them to do it. For example, if they want to have a monitoring tool or something like that inside of that compartment, they can create a compute resource here. And the project A compartment, that's actually belongs to the group A admins, right? They would have access to use the virtual network family. So they'll be able to use the virtual network family here. Right? And they can go and launch a compute resource. They can select the network, the VCN, but that's it. So remember that use only allows you to consume, not affect or modify those resources at all. So all I can do is create compute resources and use the existing VCNs that were created. So one of the points here, this is actually one of the best practice recommendations for customers who are actually federating. Okay, so in terms of defining granular access control, we want to try to narrow it down to some of the common groups configuration and common policies that would be associated with those groups, right? So when we federate access, we're going to create groups on the OCI side and assign policies to those groups, right? And then we're going to map those between the two providers, between the Active Directory or Identity Cloud servers. So if I have a global admin group in OCI that might map to my domain admin group in Active Directory, those are the folks that can do pretty much everything, right? It's if I go here to the next slide, you can see how we write that policy. So I'm going to allow global admins to manage all resources and tenants. And remember that I'm mapping the global admins to a group that actually belongs to the federated configuration, right? So those are the recommended policies. As you can see, for admins, you can write those type of policies. If you go to from the network portion, for example, for network admins, where they're going to have access to virtual network family, load balancers, and DNS. For storage admins, they have access to all these storage resources, and database admins as well. Right, so more examples here. You can have for compute admins group to have access to compute instance, and at the project level, right, we would have access to manage compute and of block volumes and database, but in a specific compartment. I'm just specify the compartment here that I'm going to have access to it, right? So you would also have the ability to use specific networks that they would have access to it, right? So I can write a policy here to allow this group to just consume the VCN from a specific compartment. All right, that was the lesson. So through that, we were able to talk about instance principle and understand how that works with your applications. We went over to some advanced policy syntax, request, function operation, and API calls. We talk about Federated and OCI with Oracle Identity Cloud Services and some of the configurations there, and some of the reference IAM model policies and IAM policies, syntax and configurations that we can do. Thanks for watching.